Team, it's Mr. Z, and today we're going to continue to practice dilating functions. Let's go ahead and turn up the heat. So, just like we did in the last one, we're going to go ahead and analyze this quadratic, and the idea is we're going to dilate it by a factor of x minus 2. So when you're looking at this, try to identify key points that are nice on the graph. And what I mean by that, when they intersect the grid lines nicely. So I'm going to see that there's a point there, right here, there, one, and so on. So the idea behind this is I'm going to go ahead and now represent these points, this information, in an XY chart. Remember, Y is the output, Y is the G of X. G of X and Y are interchangeable. And the data from this graph shows me that when X is -1, the output is 3. When X is, well, where is it? Here would be -1. What is between -1 and 0? -1/2 is going to be 0. Furthermore, at the input of X is 0, it is going to be -2. When it has an input of 1, it's going to be -3. All right, now I'm going to continue this. At 2, it's going to be 0. And over here, it's going to be passed. So between 2 and 4 is 3. At 2.5, I know that it's going to be an output of 3. So this is just me taking some data from the coordinate. I'm trying to mix some negatives and positives in order to get a better image of what's going on. Okay, what am I doing? I am taking g of x and I am multiplying it by x minus 2. So x changes in every situation. When x is -1, when x is -1, it's going to be -3. When x is -1/2, it's going to be -2.5. Likewise, when x is 0, it's going to be -2. And I continually substitute it into x minus 2. Okay, now this is where the last part comes in. I am going to graph the product, the dilation of what two things? X minus 2 times g of x. And this is going to be the outputs for what I'm looking for. I am looking for x minus 2 being multiplied by g of x. So what is 3 times -3? -9. 0 times anything? 0. -2 times -2 is a +4. +3, 0. 3 times a half. Ask yourself, what is half of $3? $1.50, $1.50. Okay, the data that I got, these inputs are the same. I'm going to go ahead and figure out the y component for each of these by looking at the final product. So I'm setting up my list. Hey, when x is -1, the cleaned up answer is 9. 0, 4, 3, 0, and 1/2. Now to sketch it, I'm going to just graph this guy. -1, -9 is going to be completely off of the graph. So at -1, -9, it is going to be way down here. At -1/2, it's 0. So you can see from this portion, it would have to rise, and it's going to be increasing when it hits at 0. Okay, now and negative 1/2, it's 0, the root. The y-intercept is going to go ahead and be positive 4. So it's going to be here. Then 1, 3. 3 is here. 1, 3. And then 2, 0. So notice how it goes up. And then it's going to come out like that and hit the 2, 0. And then at 2.5, halfway between 2 and 3, it's going to be a half a value up. A half is going to be right around here. So I know it's going to be increasing again. The key idea is that you do enough points on the graph so you're able to get out at the general idea of this graph looks like so.